Anyway, why not let us use our resources like we'll be able to in the real world?
Because I want you to understand how you're using those resources and which resources you use. The biggest problem most people have, quite honestly, at this point is they simply have a spreadsheet with a bunch of data points. They plug into the spreadsheet into their Excel program or statistics program they're using, and it spits out an answer, and they go with that answer without knowing how that answer was derived. And they may have chosen the wrong formula. They may have chosen the wrong data to go into it. They may not understand the concept of scales of measurement. We'll be choosing the wrong scale of measurement. We're using nominal data for a formula that requires at least interval data. And so they think they've done things correctly, right, using the resources they've got without understanding the process. Doing it this way, I think, gives you a better understanding of the process.
What is that? What do you call that formula at the top, the y equals dx plus a? What is that called?
It's the general line. It's a general equation for a line, or if you want for our purposes, the least squares regression line. Line of best fit, linear regression. All those terms are interchangeable. So if someone when I say calculate a line of best fit, that's the generic equation. For any specific set of data, you're going to have a specific numeric value for the slope b and for the y-intercept a. Right? And so any specific formula, like for example in homework, right? About midway through, once you calculate the slope, once you calculate the intercept, I ask, well, what's the linear regression line it predicts? That's y equals some number times x plus some number, right? But that's the generic kind of equation. It's recorded under the means, so y bar b x bar plus a, in order to calculate a as the intercept, because you're plugging in the means as the most representative paired set of scores for x and y in order to calculate the a score.
Is this test is next test gonna be over similar information, or is it object graphs and stuff?
The next test will be entirely different information than this. Although there may be a little bit of overlap depending on our time with some z-score information. After the second test, for the remainder of the semester, we are going to start talking about probabilities and inferential statistics, but I hope to get ahead of myself at this point on that.
You know any of this stuff?
Charlie, that looked crazy.
I will be impressed if we did.
Well, now she will.
Yeah.
Alright, so what do you want to go over?
Z scores. For sure. Mainly, what I feel like I'm having trouble with is knowing which columns to use, and I don't know why.
Okay. Actually, I was thinking,
Just one?
draw the slide early.
Two, just
I gotta bring it back.
thank
No.
you very much.
The ruler, 12 inches. Okay? 1 to 12. Okay? On that same ruler, this is in inches. And that's in centimeters at the top. Right?
Okay.
What's the formula to calculate centimeters from inches? You might know.
Like 2.54.
Like, exactly. That's pretty good.
Okay, cool.
You know she graduated like last year, right?
Yeah, okay now. But yes, I did.
Take your inches, multiply by 2.54, that will give you centimeters. So 1 inch is 2.54 centimeters. Right? We got that?
Yeah.
2 inches would be 5.08 centimeters. Right? So this value is 5.08. Right? And so on up. So 10 centimeters is 25.4 centimeters. Right? All right, so the ruler, it's a typical kind of ruler, I didn't bring one. Typical kind of ruler, right, has, as a physical object, like this desk, right, a length and a width, right? If I take a desk, and this side's measured in inches, and that side's measured in centimeters, right? I've also got what percentage of the desk is occupied by any given marking on it, right? So for example, I say, what percentage of the ruler itself is left of 6 inches? 50%, right? This is 50% right here, this is 50% right here, right? If I say, what percentage of the ruler is 3 inches or less? If it's 6 is 50%, what percent is there and down?
25. Oh, or what?
25% there down, right? Does that make sense? Very straightforward. What I've got, conceptually, right? I've got a value in inches, a value in centimeters, a value as percentage. If I know any one of those values, I know the other two, right? If I know inches, I can calculate using the formula number of centimeters. If I know either inches or centimeters, I can, looking at the ratios involved, right? I'll do it this way to pair it up later, right? I can look at, or look up, those values to get a percentage, right? If I know a percentage, like say for example, I tell you, 25% of the ruler is at the top end of the ruler, right? How many inches is that or higher?
3.
Top end.
Oh, 10, 9.
9, right? Make sense? Main point. I can convert inches to centimeters using a formula. I convert centimeters to inches using a formula, just inverting the proportions there, right? I can look up a percentage if I know either inches or centimeters, right? As I move down the length of the ruler, going from, let's say, start at 1 inch or 0 inch to end at 12 inches, right? The percentage gets higher, the number of inches gets higher, right? The centimeters gets higher, the number of inches remaining gets lower, right? So as I move from 1 to 2, I've now got 10 left. I go from 2 to 3, I've now got 9 left, right? Make sense? If I said, what is the percentage of the ruler between 6 inches and 9 inches, there to there, what percentage of the ruler between 6 inches and 9 inches? 25%, right? You can calculate above a certain point, below a certain point, between certain points, right? Exact same thing now. That's all Z distribution is doing. Here's my Z distribution. Actually, let me line it up a little better. Actually make it look like it corresponds to the ruler. So let's put the middle right there, and here the 6 in the middle of the ruler. Right? I've got an X score, I've got a Z score, I've got a percentage. Right? If I know a Z score, I automatically know an X score. If I know an X score, I automatically know a Z score. If I know either a Z or an X, I know the percentages. Just like this. Two numbers that go back and forth, X and Z. Right? Percentage based on the area involved. Right? And just like before, I said, if I bring down, I said, excuse me. If I have some score value, let's do the IQ stuff. Mean IQ is 100. Right? What's the mean for the Z score? 0, always, forever. That's fine. Right? So I got a positive set of Z scores above it, negative set of Z scores below it. IQ does not have to be positive or negative above it. May only got to pick your sort of typically in a reasonable sense. Right? But if I got some IQ score of, let's say, 125, right? I can calculate a Z score associated with that, and I can ask the question, what is the percentage of people in the population who have an IQ score of 125 or higher? Just like I can ask, what is the percentage of the ruler higher than 9 inches? Right? The only difference, the concept is exact, right? The only difference is, it's not a nice blocked out value, height and width. It's now curved in terms of the Z distribution. It's now infinite and asymptotic to the x-axis.
So,
whereas the ruler's finite. The ruler's discrete in terms of length of the ruler. The ruler's continuous within the ruler. Z-score is going to be continuous across the entire distribution. Right? And just like what I had a minute ago, if I got an X score, I can calculate a Z-score. If I got a Z-score, I can look up in the table to get a percentage. Okay? In the table you're going to use, if I got my distribution, that's why little pictures in the bottom right hand of that distribution. You're going to be starting with the mean, say mean of 0. There's going to be some value here, right? Some z-score value. The B column is this percentage. The C column is that percentage. Right? So as that line shifts further out, the B column gets bigger, the C column gets smaller, the z-score itself moves further away from 0, right? In terms of standard deviation units.
Wait, you said what happens? The B column gets larger?
As the z-score gets larger, well, I should say as the z-score gets further and further away from 0, because I can have a negative z-score down here, right? Same equivalent distance, those two things are symmetrical. As the z-score gets bigger, further away from 0, the B column gets bigger, right, as the percentage gets more, the C column gets smaller. Basically, it's like my ruler, right? If I'm starting in the middle, assuming the 6 is the average, okay? If I go to 7 inches, there's only 1 inch between the 6 and the 7. There's 5 inches between the 7 and the 12. If I go to 8, there's 2 inches between the 6 and the 8, and 4 inches between 8 and the 12, right? And the further I get away from the middle, right, the bigger the area gets here, but the smaller the area gets on the outside of it, right? Then it's all continuous, so you can do it in decimal point units. You don't have to be on a whole inch value, you don't have to be on a whole z-score value. It doesn't have to be a z-score of 1, or it could be a z-score of 1.26. It could be a z-score of 2.77, or whatever you want. Does that make sense? Does it help in terms of the B and the C columns?
Yes.
You forgot the A.
Oh yeah, she said that she knows
100 equals C.
100 equals C. That's so good. She see all of these letters.
Yeah.
I wish we
The
had
A is not a column this textbook uses. This column uses a Z instead. So here, if you took the alphabet, you went A, B, C all the way up to Z, and you start over again, skip the A, go down to the Z.
Yeah, so we don't use that anymore. That's a good look though. Because you would think that over there would be A, B, C, right? Pretty smart.
I don't know why this textbook uses B and C. I suspect, well, yeah, I don't know why I use A, B, C. You could have used Z, A, B. It wouldn't make a difference.
So if there was would there be a question on the test like what's the percentage of people with an IQ above 125?
Yes,
Or between 100 and 125?
or between 125 and 140.
Okay, so like so if you get a question with between, you have to find 2 z-scores?
Yes.
Yes.
Okay.
Assuming one of them is not the mean. If one of them has a z-score of 0,
Okay.
it maps straight on the table.
True.
You know, you do it. But assuming both values are not on the mean exactly, you'll have to look up the different z-scores.
So do an example
Okay.
while we're on this one. Like do what is the percentage of people who have a z-score of 125 or higher first?
Okay.
Since you already
So-
have a question.
If I ask what's the percentage of, first of all, draw it. Now, I will have you actually draw these on the test when they're necessary. You're drawing this area, right, which would correspond to say something like up here, right? Do it on the ruler. Which formula? Pick one of those.
So it would be one of the Z's.
Probably, yeah.
I just want other people to have.
Let's put it this way. Do you have a raw set of data? Do you have a list of X scores?
No.
Right? So you can probably rule out doing this stuff,
Yeah.
right? I did not say specifically
Sample or?
whether it was a sample or population. But since we're talking about IQ scores,
Population.
right? I'm an IQ and a population score of 100 here, right? This is population data.
Okay.
Unless I say otherwise, this way. Unless I say otherwise, I'll tell you which way it is on the exam, right? Typically, you're going to assume sample, but in this case, you can assume population because IQ scores and these types of numbers come from population data for IQ. If I give you a sample set of scores and say, assume this sample is representative of the population, that does not mean I'm giving you population data. That means you can use the normal distribution because the normal distribution comes from population data. Right? You're still using the sample statistics, you're still calculating Z based on the samples, but you can use the normal distribution if it's representative of the data. right? So saying things like assume it's representative of the population does not mean recalculate population data, right? It means you can use the z-score calculations, right? So, which formula?
The first one.
Second one.
What?
This one.
Oh, yeah, population, we just said that.
You said population. This formula.
That's how I be on the test.
said that. Oh my goodness, it's so good. Me too.
All right, so what's my x-score I'm going to be putting in formula? What's the mean?
100.
I have not given it to you, so you remember what's the standard deviation for population intelligence? Typically set to be
25?
Nope.
20?
Nope.
15?
15. Keep guessing multiple 5, you might get it. 15. On the test, right, if I don't give you raw data, I will tell you what the standard deviation is for this particular set of data. Right? So I'm not going to have you guess 25. I will tell you exactly what it said. So that then gives me a z-score of 1.67. Right? 25 divided by 15.
So this gets us 50% of the question. Right.
That gets you a z-score, which you can now use to calculate. You can look up value in the table. And I'm going to guess it's probably something like a 0.05.
0.0475.
So that's the area here. So if I ask what's the percentage of the population that has an IQ higher than 125, you calculate the z-score from the raw score, 125. You look up in the table the z-score to get a percentage. In this case, higher than that value is the C column.
Okay. I'm getting it. Finally.
Let me see your table. Just to make sure that y'all are correct.
I got extra tables.
Do you want one?
Yeah. At least for the purposes of today. I'll give it back.
So you're saying you didn't
And that'll be
complicate?
the answer to the question.
If the question asks what's the percentage of the population which has an IQ score of 125 or higher, yes.
How many questions on the test will involve this type of stuff? Or would it be better to tell me the percentage?
Well, the first page of the test will be essentially multiple choice questions.
Mm-hmm.
Usually the number of multiple choice questions varies from exam to exam. I think the previous test it was what, 17? Maybe? It's usually not more than 17, 18, and the fewest will be, the final will be like 10. For this one it'll be somewhere around 15 maybe.
Okay.
Right, so that'll be the multiple choice kind of stuff. After that you'll have one page each dealing with z-scores, linear regression, correlation coefficients. Depending upon individual calculations, you have to cut small. Well, the z-scores are smaller. There's basically a little piecemeal do a little part of it.
Mm-hmm.
Linear regression is calculate the slope, calculate the intercept, use line of best fit, make predictions.
And that's gonna be like the page of questions, so not all in one.
That'll be one page of questions. Yes.
Okay.
Correlation coefficient is going to be here. Here's the correlation coefficient.
So that's about maybe like 4 questions each on math.
4 or 6. Yeah.
Okay. And we have
And they
worked on
should
this?
build just like the homework.
Perfect. Question. Could you tell us what to study for the multiple choice questions? Only because the first test we had definition and stuff like that.
Same kind of thing here.
So we would need to know definition of chapters 5,
Understand
6.
the concept of the z-score.
Understand concept.
So for example, the characteristics of the curve, middle is equal to 0, the mean is equal to 0, total area of the curve is 1, right? Half above, half below the mean. Asymptotic, inflection points at the 1 standard deviation. Right?
What? I don't remember any of that.
I talked about
Infections.
it. I talked.
Oh wait, hold on.
I
think
guarantee I talked about it.
no, you did. I know you did, but I don't.
Where the curve flips from going down and out.
I
That
see.
point is called the inflection point.
Mm-hmm.
There's 1 on each side. That point occurs at positive 1 standard deviation and negative 1 standard deviation above and below the mean.
You probably have that in your notes because I just
Right.
found it in my notes. I just forgot.
It's one of the characteristics of Z distribution.
Characteristics of Z distribution. What else? I need to study this
Well,
because I was so confident
The
in
Z
the math
distribution,
part.
it represents things like continuous data, right? The original data set itself, the raw scores might be discrete, right? But the Z distribution, because it assumes population data, assumes a continuous underlying data set, right? We'll talk about a discrete